All right, this is number 63 from chapter 8. We're going to do it as a review. This problem, we have a ball swinging on a vertical, in a vertical circle. Okay, it's going around, and we're given that the length of the string is 0.80 meters, 80 centimeters. The ball has a mass of 2 kilograms. And at a point where it's 30 degrees from being vertical, okay, actually I have it going this way. I'm not sure it matters, but we're going to do it going this way. When it's 30 degrees from here, we know that the tension in the string is 20 newtons. Okay? That's what you're given. What we want to find is, what is the ball speed? So we want to know what the ball speed is at this point, and what are the magnitude and direction of the acceleration at 30 degrees from the top. So we want to know the acceleration at the top, the total acceleration. All right, so we're going to start these like we do all of them. We're going to do a free body diagram. So at this point right here, we have gravity going down. We have tension going this way. And that's all we have. There aren't any other forces acting on the ball at that point. This is kind of the tricky part here. Remember, we're going to make a coordinate system, but we got to think about at this point, which way is the ball moving? Well, its velocity vector is this way, because you always want the one axis to be in the direction of motion. So I'm going to make my axis this way and this way, so essentially perpendicular to the tension vector. Now I'm not going to call these x and y because it's not x and y. We're going to use radial coordinates. We're going to call this as the transverse coordinate this way, and the radial coordinate here. So I'm going to call them r and t. So radial component means towards the radius, or direction of a radius vector. Or tangential coordinate is the one that's perpendicular to that. So the velocity is moving in a tangential plane. Okay? All right. So what we have to do is we have to take coordinates. We have to take the coordinates of gravity and place it on the two components. But I have to realize, where is this 30 degrees measured from? Right here. So we got to be careful about getting our angle right. Notice that this is the way it is here. If I drew a line like this, then that would match this angle right here. So this angle right here is 30 degrees, which means that this angle up here, that's 30 degrees. You got to make sure you get the right angle. All right, then when we do that, we're going to break mg into components. So we have a component going this way, which is going to be mg cosine 30 degrees. And we're going to have one going this way, which is mg sine of 30 degrees. All right. Now we're going to do the radial coordinates. So we're going to do F net r, okay, the radial coordinate. Now I'm going to have positive going this way. You can make it whatever direction you want. I'm going to make positive go that way. So this becomes t plus mg cosine 30. Well, this is the direction of the centripetal acceleration. So this is where we put in our mv squared over r. And it is also in the same direction, so it's positive. So that's equal to t plus mg cosine 30. And we want to solve this for the velocity for part A. So I'm going to solve this velocity by multiplying by r and dividing by m. So I get v squared is equal to r times t plus mg cosine 30, all divided by m. And then just take the square root of that, or actually that just becomes v. This side gets the square root. And we can plug in the numbers and get the velocity. So the velocity should be equal to the square root of 0.8 times 20 plus 2 times 9.8 times the cosine of 30, all divided by 2. All right, let's make sure I did that right. And when you do that, you should get a velocity of 3.85 meters per second. So that's your answer to part A. All right, for part B, we have to say, what are the two accelerations? Well, we have an acceleration that's a centripetal acceleration, and we have an acceleration that's tangential. For the centripetal one, we know that A is just equal to v squared over r. This is A centripetal. So A centripetal is just, we know the velocity is equal to 3.85 squared divided by 0.8, or the centripetal component is equal to 18.5 meters per second squared. Now the tangential component we get from saying F net t, and the tangential component just has to be equal to m times a, the acceleration at that point. Well, we want that to be a, so this is going to be F net t divided by m, but F net t is just going to be mg sine 30. So a is equal to mg sine 30 divided by m, the m's cancel, or a is equal to g sine 30, or a is equal to 9.8 times the sine of 30, or a is equal to 4.9 meters per second squared. And the sine of 30 is a half. All right, we're not done though, because we need to figure out what this is the tangential acceleration, right? So we have the two components. We have, to draw this in a different color here, we have the tangential acceleration going this way, we have the centripetal going this way. So the total acceleration we have to do by Pythagorean theorem, or A total is equal to the square root of 18.5 squared plus 4.9 squared. Take the square root of that. So the total acceleration is 19.1 meters per second squared. And then we need to know the angle. And we're going to do the inverse tangent. And remember, it's opposite over adjacent, so it depends on what angle you want. I'm going to do it like this, so I'm going to draw it up here. So you have the tangential here, you have centripetal here, right? So I'm going to do it like this and figure out what this angle is. So the tangential is down here. So my opposite is tangential over the centripetal. The theta is equal to the inverse tangent of 4.9 over 18.5. And when you do that, you get 15 degrees. Okay, and then we have to label it. That would be 15 degrees ahead of the center of the circle. Or you could have solved for the other angle. If you solved for the other angle, you would have got 75 degrees toward the center from tangential. Notice it's kind of confusing because we don't really have x and y's to do as coordinates, but you have to do it from one way or the other. Either one of those answers is correct. And so that's the second part of part B. All right. If you can do that one, you can do pretty well. The key, remember, with these kind of problems is you figure out which way the centripetal acceleration is, and you take that net value and set that equal to mv squared over r. Remember, it can only be three things, either 0, ma, or mv squared over r. All right.